Hello and welcome back to Calculus 1, section 3.4, product and quotient rule. Oh, you can't see it yet. That's fine. We fixed it. Now you can see it. We are going to continue exploring different ways to take derivatives so that we can avoid the limit rules. And what we have now is first the product rule, which will allow us to take the derivative of the product of two functions. Now, this is the only way to do product rule. Do not invent your own ways. It doesn't work independently, each function and so on. That doesn't work. So let's write the product rule. Product rule says the derivative of f of x times g of x is equal to, easy with the furniture, f of x times g of x prime plus g of x times f of x prime. And that is the product rule. That's it. Now, you can write that in a more compact form. If you say, let f of x be u, it's still a function, right? And g of x be v, and then you can rewrite the whole thing as uv, derivative is uv prime plus vu prime. That's the shorter version of the... I also seen people write it in terms of f and g. So fg prime is equal to fg prime plus gf prime. You can do that way as well. But generally the two formulas that I boxed off are the ones that are seen most of the time. And you have to use the product rule if you cannot cheat with algebra. So let me give you an example where we can cheat. The derivative of x plus 1 times x squared minus 3x. Clearly, I have two functions that multiply each other. They both happen to be polynomials, and if I FOIL all of that stuff, I can actually kill the product. Right? So in this particular case, I can avoid using product rule because I can FOIL. And that will, let's see, that will look like this. So the derivative of x cubed minus 3x squared plus x squared minus 3x, and then one more time x cubed minus 2x squared minus 3x equal. Observe, guys, that I'm using this derivative. I keep copying this. There was a lot of issue with notation, a lot of minus ones on the exam for writing stuff that mathematically makes no sense. So obviously, if you do not write this on each one of these, whatever you're doing is just wrong and makes no sense. You have to have those because you haven't done the derivative yet. Imagine if you had 3 plus and then you have 17 minus 5 and you're working on PEMDAS and you know that you have to do 17 minus 5 first. So in the next row you go 3 and then you write 12. You didn't write plus. which is a mathematical operation. So now you can read this as either 3 times 12 or 312, and it makes no sense because you didn't put plus there. Limits and these ddx, they're mathematical operations, operators. So you have to use them in every single step until you use them up to do the calculation. So I get to copy this derivative on every single line until I am ready to do the derivative, which is now 3x squared minus 4x minus 3. Now this step doesn't have ddx because this is the derivative. I used up ddx to change this polynomial into that polynomial. So that's basically what's happening here. So now what I did is I used algebra to kind of to change my problem from multiplication of polynomials into a single polynomial, and then I took the derivative. But I can also solve this problem using the product rule and get the same answer. So what is ddx of x plus 1 times x squared minus 3x using the product rule? Well, this is u, this is v, or let's use f and g, it's easier maybe, I don't know, whatever, f and g. So it says copy the first derivative of the second plus copy the second derivative of the first. Let's do it. Copy the first, x plus 1, derivative of the second, 2x minus 3, plus copy the second, x squared minus 3x, times derivative of the first is just 1. Because derivative of x is 1, derivative of plus 1 is 0. FOIL, to simplify, we are looking for this answer. We have to get the same. So 2x squared minus 3x plus 2x minus 3 plus x squared minus 3x. Combine everything. 2x squared, no, 3x squared. These are the x squares. And then x and minus x, and then minus 4x and minus 3. Yep, same. It's the same. So if you use product rule, you know, if you use product rule, you know how to compute these things. Now you might ask, well, why would I learn product rule if I can multiply with algebra? Hehe. Go for it. Can you multiply now? No, you can't. Right? You have to use product rule. Again, the first function is f, second function is g, fg prime plus gf prime. Let's go. All right, are we ready? Copy the first, e to the 2x, derivative of the second, just 2x, plus copy the second, x squared plus 3, times derivative of the first, 2e to the 2x. Remember that a that pops down? Now, we're not done. We are eventually going to go into chapter 4. And in chapter 4, you have next step equal to 0. And then you have to solve the equation. So it's good to start now getting into a habit to factor your answer as far as you can. In this case, we can kick out 2e to the 2x. When I kick that out from the first term, all it's left is very good. Now, from the second term, this is out, so what's left is x squared plus 3. So what is the simplified version? 2e to the 2x times x cubed plus x squared plus x plus 3. And that would be simplified answer. Now, if I have to set this equal to 0, like in chapter 4, I set the first to 0, set the second to 0, and I keep computing stuff that I need to compute later on. So get used to factoring quickly. So one more. What is the derivative of? And now we have e to the 5x times 3 over x to the 4th.
Bless you.
No, I'm blessed. Okay, so we start by writing this as the derivative of e to the 5x times 3x to the minus 4. And now we have our f and our g. We are looking for fg prime plus gf prime. So copy the first, e to the 5x. The derivative of the second is negative 12x to the negative 5, plus copy the second, 3x to the negative 4, times the derivative of the first, 5e to the 5x. Now, I am going to actually first simplify this and then factor things out. So I have negative 12 e to the 5x divided by x to the positive 5 plus 15e to the 5x divided by x to the 4th. Do we all see that? So now the question is, what is common? So we can kick out 3 e to the 5x, and we can also kick out e to the x to the 4th. What's left in the first parenthesis? Negative 4 over x. What's left in the second parenthesis? What's left here? Just 5. Nice. So what would be the final answer over here? E to the 5x over x to the 4th times 5 minus 4 over x. That's the answer. Again, if you need to go equal to 0, you set each one to 0, and then you keep solving individual equations. That's the product rule. You either know the formula or you don't. Alternative to not learning the formula is to crank the limit, and good luck with that. All right? Well, yeah. There are always ways. The next part is the quotient rule. Ready? Again, formula which you memorize and use. I told you already, right? Chapter 3 is all about memorizing formulas to do the derivative so you can avoid doing the limit. Your choice not to memorize the formula and then use the limit. All right? So that's the bottom line. So here is the formula for quotient rule. The derivative of f of x divided by g of x is, and now we have the division line. In denominator we have g of x squared. In the numerator I have g of x times f of x prime minus f of x times g of x prime. For g is gf prime minus fg prime divided by g squared. Whatever. Again, anytime when stream dies, you have my previous lectures. There are about 1,000 videos on my channel from me teaching this stuff every semester. They don't delete anything, so just leave it there. You can watch this lecture or all previous times. Just do the search in the channel for 3.4 within the channel. And 3.4 you can only get Calc1 or pre-Calc1 lectures. So you'll easily sort by the title. Quotient rule. Great. Let's do examples now. You have the formula. So let's find the derivative of 3x squared plus x minus 1 divided by x cubed plus 6. We take the denominator and we square it. And then we put the denominator as is times the derivative of the numerator, which is 6x plus 1, minus copy the numerator, 3x squared plus x minus 1, times the derivative of the denominator, 3x squared. Did I mention this is going to be long? It's going to be long. Welcome back.
Thank you.
Now we simplify. FOIL, distribute everything, and collect like terms. So we do all of that stuff now. 6x to the 4th plus x cubed plus 36x plus 6 minus 9x to the 4th minus 3x cubed and plus 3x squared. You do not expand the denominator, there is no need. X to the 4th, that's going to be negative 3x to the 4th. Cubes minus 2x cubed. Single x, no, x squares now, so plus 3x squared plus 36x plus 6 over x cubed plus 6 squared. Oh wow, this one term, so we can't kick 3 out. That's okay. This is the answer. So derivative of a quotient. Here's the problem for you. Ready? E, the 3x divided by x squared plus 1. Have fun. F on top, G on the bottom, right? We're looking for GF prime minus FG prime divided by G squared. All right, so what do we have? We have division line. We first do the square denominator. Then we copy denominator as is, times the derivative of the numerator, which is 3e to the 3x, minus copy the top, which is e to the 3x, times the derivative of the bottom, 2x. So what is the only thing we can kick out? Yes, e to 3x. What's left? Well, when you kick out e to 3x, you have 3x squared plus 3, when you distribute the 3, minus 2x over x squared plus 1 squared. And now we put this in descending order, so 3x squared plus minus 2x plus 3, x squared plus 1 squared. And that's it. Ready to set it equal to 0 and get stuff. One more problem, and we're done. Every section should have this problem. Find a tangent line. Find the equation of the tangent line at x equals 3 for f of x equals, let's go x equals 0. For f of x equals e to the 2x times x squared minus 1. Okay, minus 1. X squared minus x minus 1. Better. So what is the procedure for tangent line? We have to find the derivative. Then the slope is the derivative computed at point that is given, in our case 0. The y value is also computed when you plug in 0 in the original function. And then you have to use y equal mx plus b, and done. So these are the steps. What's different is the type of the derivative, right, for section to section. The only thing that differs in this procedure is which type of the derivative you are going to use to come up with the derivative procedure, I mean. So let's go. F prime. Well, F prime is going to be, copy the first, it's a product rule, derivative of the second, 2x minus 1, times, plus, copy the second, x squared minus x minus 1, times the derivative of the first, 2e to 2x. So f prime of x is equal to e to the 2x, and then in parentheses, we have 2x squared, 2x and negative 2x cancel, and this is negative 2, negative 3, according to my calculations. Is this good? Anyone? Yeah, whatever, right?
Sure.
It's snow tomorrow, so who cares?
Exactly. I can't.
Okay, well, put that out there. Good. Points right there. So to find the slope, we will compute the derivative at 0. So we have e to the 0, 2 times 0 squared minus 3. So the whole thing is negative 3. Right? E to the 0 is 1. So we found that the slope is negative 3. We plug in, now to find y, we plug in 0 in original function. So that's going to be e to the 0. And you have 0 minus 1. And that's all going to be negative 1. So that gives me the point 0, negative 1. Plug everything in y equal mx plus b to get the equation. Y is negative 1, m is negative 3, x is 0, plus b, so b is negative 1. Which is clear because this is the y-intercept point, x is 0. So what is the tangent line? Tangent line is y equals negative 3x minus 1. Procedure for this problem is going to be the same for every section of chapter 3. The only difference is what type of the derivative you get to do here. Is it a basic? Is it trig? Is it product rule, quotient rule, chain rule, implicit differentiation, logarithmic differentiation? We're going to have all these different ways to take derivatives. The only thing that changes in a tangent line problem is which type of the derivative you have. Slope will always be when you plug in a derivative. Y will always be when you plug in a into original function. And then the procedure to find the line is from algebra. You have a point, you have a slope. So you either use point slope formula or y equals mx plus b. And that's that. There's nothing else left. So let's restart for the next. Ciao.